Yes, Arun, are you there in the group? Really exhausted, yeah. First class itself. Informing the group to join as fast as possible, Arun. Physics force and laws of motion. We'll have revision of forces and laws of motion. I think I have given that question only. Mansi has given. She told give revision of forces and laws of motion. So you have revision of forces and laws of motion. Okay. Okay. Check this one out. So look here. What's the question they're asking here is, first is multiple choice questions. The inertia of a moving object depends upon. So inertia of a moving object depends upon what factors, can you tell me? Inertia of a moving object depends upon what factor? Inertia of a moving object depends upon. Inertia of a moving object depends upon. Come on, say the answer. Informing the group to join as fast as possible. Inertia of a moving object depends upon. Yes, thank you so much. Inertia of a moving object depends upon C. Very good. Inertia of a moving object depends upon momentum of the object, speed of the object, mass of the object, speed of the object. So we already know that inertia depends upon the speed of the object. I hope you might have understood. Inertia depends upon speed of the object. Inertia is depending upon the speed of the object. That's what. So inertia depends upon speed of the object. Yes. So now we are going to monkey. Inertia depends upon speed of the object. Last time I'm asking from you. Inertia does not depend upon speed of the object. Inertia depends upon mass of the object. Inertia depends upon mass of the object. Good evening, madam. Inertia depends upon mass of the object. So if somebody will be asking me what inertia depends upon, so inertia depends upon mass of the object. Newton's second law of motion gives Newton's second law of motion gives a measure of velocity, force, momentum, or rate of motion. Wow, this is a good question. I'll be explaining some part, but first to type the answer and send me the answer. Newton's second law of motion depends upon what it is explaining actually. Newton's second law of motion explains what? Newton's second law of motion explains what? Newton's second law of motion, it is explaining what? Tell me fast. Newton's second law of motion explains velocity, force, momentum, or rate of motion. What it is actually explaining? Velocity, force, momentum, or rate of motion. Force. The answer is absolutely correct. Newton's second law of motion depends upon force only. Sir, in which language you are typing? What is that language? And what actually that is? Yes. I don't know Kannada. If you are writing means either, I don't know what is that. Fine. Now look at, we'll go for the third question. The inertia of an object tends to cause object what? What in inertia of an object tend to cause? Inertia of an object tends to cause what? Inertia of an object to increase its speed. Does inertia changes the speed, increase the speed, decrease its speed to resist a change in its state of motion or to decelerate due to friction? So what does inertia is capable of? Chennai. So now look here. So what is the speciality of inertia? The speciality of inertia is it restrict inertia. This is the change in the state of the object. That's absolutely correct. Inertia restrict the change in the object. So you need to understand that once if somebody will be asking you, so inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. Understood or not? To change the state of rest or motion, you need to apply an external force, and I have given the state name as Chennai. Okay, so that's the most important part. I hope you might have understood. We'll go for the third one. An unbalanced force is necessary. Come on, go for it. An unbalanced force is necessary. I hope you might have understood this one. An unbalanced force is necessary. Say Santosh, I'm in class right now. You post message and inform me. So now look here. An unbalanced force is necessary for an object to be at rest in motion with a constant velocity or accelerated. All of the precedings. Which one is the correct answer here? Can you say me? Fourth question answer. What is the correct answer here? An unbalanced force is necessary for an object to be at rest. See, if unbalanced force will be there applying on an object, the object will not be at rest. The object will be accelerated actually. Understood or not? The object will not be at rest. So here if somebody will be asking you in motion with a constant velocity, no, that's also not the correct answer. It will be accelerated. An accelerated object will actually be at unbalanced force. So unbalanced force is letting the object to have acceleration. I hope you might have understood this one. So now we will go for the next one. Yes. Hello everyone. Good afternoon everyone. Good evening everyone. Shall we focus to the work please? Can we? Next question we will go. Now let's check this one. When a toothpaste tube is squeezed, its shape changes. This is an example of, so when you are, okay, so when you are squeezing a toothpaste, what will happen? Its shape is exactly changing. What does it is showing? What does it is showing? Is it showing balanced force, centripetal force, unbalanced force, centrifugal force? What it actually it is showing? Understood or not? When a toothpaste is exactly squeezed, so when you are squeezing a toothpaste, understood or not? So yes, when you are squeezing a toothpaste, the shape is changing. Is it a case of, that's what I was knowing that you will say unbalanced force. I was waiting for it. And this is the wrong answer. Come on, say. The answer is absolutely wrong. That's not the correct answer first. Nothing can say. What is the answer? What is the answer? Is it balanced or it is unbalanced? Think once nicely. Because when we are putting pressure in one direction, the pressure is directly distributed to the other part to balance it. So is it a balanced force or unbalanced force? Tell me, is it going to be a balanced or an unbalanced force? I hope you might have understood. Hmm. Hey, the answer is wrong. What is going to the next question? I'm waiting for it. The answer is absolutely wrong, and you are saying that go to the next question. How? First give correct answer, then only I'll go to the next question. Answer is not correct, madam. So rethink and tell me and give me the correct answer. Again, one more time I'm telling. When a toothpaste tube is squeezed, its shape changes. This is an example of the force responsible for this is an example of, so this is example of what type of force. Now you are correct. The force is exactly responsible for a balanced force. Why balanced force? Why not unbalanced force? Because it is not accelerating, it is exactly changing the shape. So if you might be performing and if you might be changing the shape, once the shape is changed, means it's a case of balanced force only. I hope you might have understood. So it's a case of what? It's a case of balanced force. So the force is balanced here. That's it. That's what we have to check here. So here the force is actually balanced force. Got it? Not unbalanced. I hope you might have understood. Arunisha, the force is balanced here. It's not unbalanced. Right now, class 9. Yeah, you take this book and practice. That's a balanced force. If you have said balanced force means your answer is absolutely correct. If you have said balanced force means correct. If you have said unbalanced force, then only the answer is wrong. Balanced force means your answer is absolutely correct. I am taking it. Understood? But if you have said unbalanced force, then you are wrong. What comes, sir? Got it? Yeah, but I got delayed because of some very mental people now. I was unable to start my class in time. Okay. 10th, right now, if I will say time means 9th will start shouting on me. So I need to check. I think 5:45, 15 minutes, 20 minutes delay. I need. Otherwise, I won't be able to. Why? But today is science. Right now you are having maths with you. And science, electricity, I am going to be practice. So you think nicely. Fine. Let's go for the next question. C. Which of the following is the equation of motion of a body? Which of the following is equation of motion of a body? P is equal to mv, that is momentum. F is equal to ma. V minus u is equal to at. Or ft is equal to mv minus mu. What is the correct answer here? Correct only. Let me check. Which of the following is an equation of motion of body? Last I am asking equation of motion of body and you have given the answer V minus U is equal to 80. See, if you might have given the answer A, you might have been wrong because it is momentum. Momentum is mass into velocity and it depends upon inertia. So not working. Second, force is equal to mass into acceleration. It depends upon the external energy. Third one is equation of motion, which will be like if an object will be moving, it will be giving an acceleration with a velocity. So the correct answer is C only. Absolutely correct. So C is the correct answer. B minus U is equal to 80. Well done, super. So now you go for the next question. Go for the next question. Question number 7. Don't message and call. I'm going to switch off my phone. That's it. Story over there. Now look here. When a rubber balloon held between the hands is pressed, so now look here. When a rubber balloon held between the hands is pressed, its shape changes. This happens because, so I'm going to keep a balloon in my hand and I'm going to squeeze it. So when I'm squeezing it, its shape is changing. Why? So rubber balloon is shape is exactly changing. Why? This is because, say, is it a case of balanced force? It's a case of unbalanced force. What is exactly making it possible? Means if I'm taking a balloon and I'm going to squeeze it, the shape of the balloon is exactly getting deformed. Just now, few seconds before, we have solved one question like this. So now you tell me what is the answer. Balanced force act on the balloon, unbalanced force act on the balloon, frictional force. So there is no case of frictional force here. There is no case of gravity. How gravity can be accountable here? So definitely gravity and frictional force we need to remove from that case. Only two cases are there, balanced and unbalanced. Fine. So the correct answer here will be balanced force. So only one force will be acting and that is balanced force because the balanced force will distribute to the other part of the balloon. So when you are squeezing a balloon, what actually you are doing is you are taking the shape. See, it is having a volume and air is present inside. So it is not having a specific what do you call shape. Compressibility will change and distribute the air in different regions because it is elastic. Because of that, the balanced force will be exactly acting on it. The balanced force will shift the force in which direction where it will get away out. Understood? So that's the correct answer. So correct answer is seventh answer is A. I hope you might have understood. Yes. We'll go for the next question. Inertia. Inertia is what? Inertia is the incapability of a body to change its state of rest or motion until and unless an external force is applied on it. So if I really want to push a ball means I have to overcome its inertia. Sound. See, right now that ACS was having exam, so that Arunisha told we need revision, so I started revising. If you say means, I'll start sound in between also. I have no problem in starting sound. Not at all. One time also I'm not having problem. I can start sound. If you say today itself, I will start sound. I have no problem. I can start anytime. Without sound is a type of vibration in the student. So without material, you want me to start sound. Next class tomorrow, maybe I'll start. I'll teach sound without any formula, anything. I'll start blabbering and full chapter I'll finish. From infrasonic wave to ultrasonic wave, everything I'm teaching in sound. Understood not? From what you call amplitude to everything. But here, compression, rarefaction, everything I'll teach. But for that, I need a back support here. You have exam on January. See, both the cats started fighting. One is telling, auntie, you teach this. Another is telling, auntie, you teach sound. So I'll do one thing. Parallelly, I will be starting your class. Extra class sound I will teach. 9 o'clock, not today possible, but maybe tomorrow or Sunday, I'll start teaching sound. Is it okay for you? Then you say, yes. If it's not okay, say no. Only that much. I hope you might have understood. Now I have switched off my phone. I'm switching it on. I'm also having online January. What is the meaning of? I hope you might have understood this one. Come on, shall we go for the next one, please? So now look at. We'll go for the next question. Shall we go for the next question, please? Sometimes I don't know nowadays I'm losing patience. Sometimes I feel like I never went for a physical fight. Sometimes I not feel like fighting. 2 minutes you are not giving me, yaar. What is this? Now look at inertia. So inertia said objects in motion causes changes in motion is the result of a net force is directly proportional to mass of an object. So what is the correct answer? Inertia. Come on, say. 8. What is the answer? First part is set object in motion. Inertia is incapability of changing the state of rest or motion of an object until and unless an external force is applied on it. So it is not going to set any object in motion. Gone. Is the result of net force? No. It result of net force causes change in motion. No. First is directly proportional to mass of an object. Inertia means I'll be like this means I'll be like this. I will not change anything until and unless you have to come and push me and change me. So you have to apply force more than my inertia. Understand what? Means my force, you have to apply more force to move from me from here. So that's what is inertia. So definitely inertia is directly proportional to mass. I hope you might have understood. Inertia is directly proportional to mass. I hope you might have understood. We'll go for the next one, please. A passenger in a moving train tosses a coin which falls behind him. This shows that the motion of train is accelerated, balanced, retarded along circular track. So why means I am going to toss a coin in train and the train is exactly the coin is moving back of me. Understood not? The coin is moving back of me. Why the coin is moving back of me? What is things responsible here? What is the case because of which the coin is exactly going back of me? The coin is not moving forward. The coin is exactly going back of me. What is the case? The coin is going back of me. The reason is the train is accelerated, balanced force, retarded. Retarded means it should not be going back of me now. It should be going front of me. So front, if it is retarded, means it will be going front, why it will go back? Correct now. So this is retarded is not possible. Along circular track, no, that's not the case of circular track. The circular track, again it will go left or right, it will not go back. Understood? So this is also not possible. Balanced force means it will come here in my hand. So here, what is the correct answer here is accelerated. Understood? What is the meaning of accelerated? The train is accelerated because of which when you just toss the coin is going back of you. I hope you might have understood this one. We'll go for the next question, please. Force is defined as, what is force defined as? How can you define force? Check. Tell me. How can we define force? Change in momentum. Force is change in momentum, mass into velocity is momentum. Is force change in momentum? Rate of change of momentum? Force is rate of change of momentum? Or what? Third is the quantity that opposes inertia, the quantity that keeps the velocity constant. Which one is correct answer? Come on, say it fast. Pakka. Super. This one you give answer. Whatever sound box will there, it will also go one day from my hand. My voice is audible. Okay, previous question, but at least this question you answer, na? Thank you. Answer. Oh, seriously. Today mental. Come on, go for it. B is the answer, rate of change of momentum. Nandri, I was waiting for this moment only. Thank you so much. Because tired of waiting for these answers. See, rate of change of momentum is force only, na? Because rate of change of momentum is what? Mass into velocity is momentum. So mass into velocity, change of momentum, change in velocity, and that will be exactly E. Thank you so much. At least you answered. So rate of change in momentum. Don't give me that type of reactions here. Heart will fail. Rate of change of momentum. Mansi anti-disturbing way. All problem solving is. When also when no problem will be there, then Mansi auntie will come and disturb. Oh, whatever all problems she will gather, she will come and she will push me in that. Okay, punch you. Now okay, rate of change of momentum. So rate of change of momentum, correct. Sorry. Rate of change of momentum is the correct answer. Rate of change of momentum is coming as the correct answer. Now, when a hanging carpet is beaten with the stick to the other particles start coming out. This phenomenon can be best explained by making use of, come on, say answer. Stop. Okay, so Newton first law of motion, Newton second law of gravitation, Newton first law of motion, third law of motion, Newton second law of motion. Which one is mostly explainable here? See, Newton's first law of motion says what? Any object will be at rest means it will stay at the state of rest. Any object will be in motion will stay at the state of motion. Any object will be at the state of changing position means it will keep on changing its position until and unless an external force is applied on it. So if we need an external force application will change everything. I hope you might have understood. So external force application will change everything. Understood now? So here, it is actually when you are taking a carpet and with the help of a stick you are beating the carpet. What happens? The dust present in the carpet will be at rest. But when you are beating the carpet comes in motion. So when the carpet is coming in motion, at that time what will happen? The carpet will be exactly moving and the dust is at rest, so dust will fall down, and that's the mechanism through which we can clean the dust from the carpet. So here it is absolutely the first law of motion. I hope you might have understood it's Newton's first law of motion. Is it acceptable? Yes, acceptable. That's Newton's first law of motion. Now the rate of change of momentum with respect to time is rate of change of momentum with respect to time. Rate of change of momentum with respect to time. Rate of change of momentum with respect to time. Rate of change of momentum with respect to time. Formula, sir, madam. Come on, say. Rate of change of momentum is nothing but, I will not say. Why more? Rate of change of momentum. Jita, what is rate of change of momentum? Rate of change of momentum or not? What is rate of change of momentum, everyone? Rate of change of momentum is? Why this much silence is there? That is force only. Yes. Rate of change of momentum is nothing but just few seconds before I explain, rate of change of momentum is nothing but force. So when somebody will be asking you, rate of change of momentum is force, then force is exactly equal to force is equal to mass into acceleration. Mass unit is kg, acceleration is meter per second square. So it will become kg meter second to the power minus 2. So kg meter second to the power minus 2, that's the correct answer. So first option is going to be the correct answer. Kg meter second to the power minus 2. Why? Because rate of change of momentum is nothing but rate of change of momentum is nothing but this will come. Okay, fine. Shall we go for the next question? Pakka, pakka. Question number 13, go for it, please. Without answer, you are doing like this, huh? Okay, fine. So when we talk to, when we talk to a force acting on a body, it usually means when we talk. What does that mean? When we talk to a force acting on a body, it usually means electrical force, balanced force, unbalanced force, nuclear force. Oh, understood. What is that question? When we talk to a force acting on a body, when we talk to a force acting on a body, what does that mean? C, unbalanced force. Yes, actually this is correct only. When we talk to a force acting on a body, it means it is exactly an unbalanced force. It's not electrical, it's unbalanced force. Okay. Now look here. The acceleration of an object is inversely proportional to its mass. Acceleration is inversely proportional to its mass, it is telling. Sharmila, class is 5:30 I said, but now the class shifted to 5:45. Okay. I'll start at 5:45 sharp. Electricity I'm going to teach, and today I'm going to give some current to many of you. So many of you will get nice chocolates from me. Get ready because paper correction done. Most of the intelligent children. You got only public, I will not say. Apuru I will touch. Understand? Public meeting is not allowed. So now look here. The acceleration produced by a force of 5 Newton acting on a mass. Come and solve this question. But first question, an acceleration of an object is inversely proportional to its mass, directly proportional to applied force, resisted by inertia, resisted by inertia, all of this. So what can be the correct answer? What can be the correct answer for this? So you need to be very careful when you are solving this question. This is a very good question. Think nicely. The acceleration of an object is any object acceleration or yes, that's absolutely correct. Super, bless you. Understood. Now you can do this. So now look here. Inversely proportional to its mass. Yes. Acceleration will be inversely proportional to mass. Absolutely correct. Acceleration is inversely proportional to mass. Why? Because mass force is equal to mass into acceleration. So it is inversely proportional to mass. Next, directly proportional to applied force. Directly proportional to applied force. Resisted by inertia. Yes, it is resisted by inertia. All of resisted by inertia, all of this. Correct answer is coming as all of this. Absolutely correct. Is it done? Now for 15th question solve. Try this question. The acceleration produced by a force of 5 Newton acting on a mass of 20 kg in meter per second square is the acceleration produced by a force of 5 Newton acting on a mass of 20 kg in meter per second square. Can you say? So the acceleration produced by a force of 5 Newton, force is given. Force is 5 Newton, mass is 20 kg. So we know that F is equal to ma, 5 by 20, 1 by 4, so 0.25. So what is the correct answer here is 0.25. So the correct answer here is 0.25. Understood. The correct answer coming here is 0.25. Now we'll go for question number 16. Come on, go for question number 16. According to the third law of motion, action and reaction. This question is so easy, you can answer. Come on, come on, come on. According to the third law of motion, action and reaction are always act on the same body but in opposite direction, always act on different body in opposite direction, have same magnitude and direction, act on either body and normal to each other. This is a very good question. Question number 16, try this question. Action and reaction. C. You think C is the answer? Switch on, but reduce the speed. Fine. The correct answer here is B. That is always act on different bodies in opposite direction. Understood now? So it will be action and reaction will be acting on different bodies in opposite direction. That's good only. Absolutely. Shall we go for the next one? The rocket works on the principle of conservation of mass, energy, momentum, or velocity. So rocket will work on which one? Think nicely and then give the answer for rockets. What is exactly it is working on? Absolutely correct. For rocket, the principle it is exactly working on momentum. Absolutely correct. So rocket is exactly yes, it is working on momentum. Both of you are absolutely correct. The principle it is exactly working on momentum. Super. So we'll go for the next question. Let us solve this question. Question number 18, right? Good. Question number 18, right? A boy of mass 50 kg standing on the ground exert a force of 500 Newton on the ground. So force exerted. Nice to see you, sir. How are you? 10 Newton. Check one more time. Third is wrong answer. A boy of force this much kg. So force is given how much to you? Let's talk about this. Force is exactly coming as a mass is given as a note of 50 kg. Force is given as 500 Newton on the ground. The force exerted by the ground on the boy will be how much is exactly? So equal and opposite. So how much exactly it is there? That much it will be exerted. So 100% the answer will be 500 Newton. The answer will come as 500 Newton here. How much energy it is exerting? That much energy it is going to experience. So answer will be 500 Newton. Same as that of that. Shall we go for the next question, please? Question number 19. Go for question number 19. Come on, go for question number 19 and 20. Finish it. So let's see. A fielder pulls his hand backward after catching the cricket ball. This enables the fielder to exert large force on the ball. Definitely the fielder hand will be going up. Second is keep the ball in hand firmly. No, not at all. Increase the rate of change of momentum. 100% no. Reduce the force exerted by the ball? Yes. To reduce the force exerted by the ball and to receive it gently, the fielder is exactly going to do like that. Understood? It's not to increase the force, it's to reduce the force. That's the correct answer. The correct answer is to reduce the force. For reducing the force only. Yes, the correct answer is for reducing the force. Can you say the physical quantity which makes it easier to accelerate a small car than a large car measured in unit S, which physical quantity is exactly capable of letting a small car to accelerate easily in compared to that of a large car, this big size car. Which one? Come on, say answer. Okay, the correct answer here is kg meter per second square, that is force. Force can be applying on a body will definitely help the body to move, specifically if the force is not that much. Understood? So I hope you might have understood this one. Fine. So question number 20 questions over. Fine. Yeah, beta, because kg meter per second square is the unit of force. Kg meter per second square is the unit of force, and they are asking about force only. So kg meter per second square is the unit of force. Check that one out. Kg meter per second square is the unit of force only. I hope you might have understood this one. Bye. Bye bye. Arab? Assertion reason who will do? Come on, go for assertion reason. Hey, don't make noise. Actually, to move a body, it has either to be pushed or pulled. Force generally denotes push or pull or the action which deforms an object. So, assertion reason, can you tell me what is the correct answer? What is the correct answer for assertion reason? I'm having this force. So can you tell me what is the answer, beta? That's not difficult. Actually, it is a. I mean, live class, everything is getting recorded. What you people are doing? First, actually, what they are telling that to move a body, it has either to be pushed or pulled. That's correct only. So if I want to move a body, I have to either push a body or pull a body. Understand? So that part is correct. Both are true. But beta push or pull is exactly a type of force, and its content is not explained here. So force generally do not push or pull out the action which deforms an object. So definitely this state is also true, but it's not actually explaining the part. So 100% it is B, it is not A. Understood not? So it is B because it is not changing, it is not talking about the rate of change of momentum, it is not talking about the force definition. So since it is not talking about the force definition, that means B is going to be the correct answer, it's not A. I hope you might have understood this part. Fine. So I'm going to keep the class still here. I have class with 10th class. Fine. So tomorrow sound chapter also you want, yes, both are true, but they are not explaining each other. So tomorrow I will be keeping sound chapter also and maths also. You just inform me what and all things are there, I'll be explaining and I'll be keeping it. Is it okay? Bye. Okay, another question. Okay, fine. Bye bye.